Hello everyone, my name is Il and I'm a co-founder and research scientist in Cochl. And in this time, I will briefly introduce about sound AI and mostly focus on what sound is and how we use sound as a data for sound AI. So we will focus on the data acquisition and signal analysis part in this presentation. So for this seminar, I have two main goals which I hope to be achieved from you. So one is, at least I want to make you can pretend you know something about sound AI. So you don't need to be an expert about sound and sound AI, but I hope you can have some minimum knowledge about what sound is. And second goal is I want to make this seminar as easy as possible. So no matter who you are and what your background is, I hope you can understand this seminar well. So let's start this seminar. So first, what is sound AI? So basically, when we say sound AI, it means that we want to make a machine which can listen the sound like a human is listening. For example, when the dog is barking, then we can hear that sound by using our ear and we can recognize this is a dog barking sound. So if we can make robots which can listen and understand that sound, we can say that we made the sound AI system. So for this course, then we have to make an answer for several sub-questions here. So first, we have to understand what sound is, and we also have to know how humans are listening. And after that, we also have to know how we can mimic this process to robot to behave like a human being. Focus on answering these three questions. So first question is, what is sound? So there are several definitions about sound, and it depends on different domain. Most physicians say sound is basically a vibration that propagates as an acoustic wave. Meanwhile, some psychologists say the sound is kind of recession of such waves and their perception by the brain. We cannot say this is the exact definition of sound, but it gives us some meaningful information about sound. So let's focus on the first definition about sound. So basically sound is a vibration, which means that when we play a guitar, basically you need to play a string. When the string is vibrated, then it makes some periodic pressure to the air. The air pressure arrives to your ear, then you can recognize these changes of the ear sound by using your brain. It is the same when the ear is replaced to the microphone. So basically the microphone receives this wave energy and it changes this energy to the electrical signals. So the signal can be considered as some data, the sound data. So since the sound can be defined as a vibration, we can imagine that the speed of this vibration is matter. When the sound has low pitches, then it means that the frequency of vibration is relatively low. Meanwhile, when there is some high pitched sound, then it means that the vibration has a higher frequency. If we talk about some musical information, when something is vibrated in 20 times per second, then it makes some la sound. If the vibration makes 440 vibration per second, this is also la, but it has a 1 octave above. So here we can see that when the vibration per second is doubled, then musically it means that the pitch is 1 octave higher. And because the vibration speed of the sound is an important factor to describe sound, we can make an alternative representation of the sound. From here, the left figures shows the vibrating patterns of each sound, which is very intuitive to understand, but it's also very redundant because it's mostly periodic. So we can summarize this information and just represent it as some frequency information as a right figure. From here, you can see that the below one has a higher frequency compared to the above one, and so the below one has a higher pitches compared to the above. And another important feature to describe a sound is a timbre. From here, you can see the several frequency components to describe each sound. The above one and the below one share some same information, and the left one and the right one also share some similar information. When we compare the above two figures, then it has a similar spectral envelope, which is denoted as a red line, but each frequency is quite different. So the right above one has a bit higher frequencies compared to the left one. From here, we can imagine that maybe the two sounds have similar timbre. So actually it sounds like E sound, but the right one has a higher frequency. Two figures describe the lower pitched E sound and the higher pitched E sound. And when we think about the below two figures, it also has same envelope, which sounds like U. But similarly, the right one has a higher pitched U and the left one has a lower pitched one. So when we know it's the pitch and timbre of the sound, so we can briefly understand what sound is. Another important thing about the sound is the harmonic components or harmonics, because here you can see most of frequency components are occurred periodically. So this is actually very important features to describe the sound. You can just know that these harmonics are existing in sound, and these are very important features. Now we know what sound is, so how we listen, how humans are listening to sounds and understand it. Based on the definition about what psychologists said, so sound is a kind of reception of such waves. So it's not just the vibration, but the reception of these vibrations. So this is ear. The ear can be divided into several parts. The left part of the figure is the outer ear. The left part, including cochlea and tube, is your inner ear. Technically, the outer ear gathers all the sound. To get more sound efficiently, it has a very big shape. The gathered sound passes through the corners, and it makes some vibration into the eardrum. So the eardrum is kind of some sensors which changes some air pressures into the actual vibration. After we changes the air pressure into the vibration, and we can consider it as a signal which can be detected by brain. You can see the cochlea, which looks like some snail, and it changes vibration into the electric signals, and it sends it to the brain. For your information, our company name Cochl is based on this organ, the cochlea. So when we see the details of the cochlea, this is kind of microphone, but not just a single microphone. It's kind of series of the many microphones which focus on specific frequency. At the very beginning part of the cochlea only takes some sound information of some higher frequencies, and the deeper part of the cochlea takes very lower frequencies. It can be described as some filtering process and the sound acquisition process. All the input sound is first divided into multiple frequency ranges, and each part of the cochlea takes each signal depending on its frequency band.